Today we are going to deal with graphs that are important for the chapter. First off, we'll begin with displacement time graphs. Okay, so note the slope of line and displacement time graph represents velocity. Okay, so the slope here represents velocity. So first graph we'll see here is this one. I'm not using scale and pencil, but make sure make sure you use scale as well. I'm mentioning displacement with S, it's the usual symbol, and representing time with T. Okay, so in the y-axis I've taken displacement, and in the x-axis I've taken time. So say displacement is in kilometers and time is in hours. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. So say the graph given to you looks somewhat like this. A straight line. Okay. Understanding of graph is very important. Here, as you see, with change in time, as the time is increasing, first it is 1 hour, then 2 hours, then 3 hours, then 4 hours, then 5 hours. But say this is the initial point, say this is 4 kilometers. So at time 0, the body was still at 4 kilometer distance. At 1 hour, it is still at 4 kilometer of distance. At 2 hours, still 4 kilometer distance. 3 hours, still 4 kilometer distance. 5 hours, again, this is still 4 kilometer apart. So with increasing time, the displacement is not changing. Hence, the body is in one fixed position. Since the body is in a fixed position, this graph represents body at rest. Okay. So here velocity is 0. Okay. Another thing, we denote angle by theta. Okay. So this line is a line parallel to the x-axis. So the angle this forms with the x-axis, so that will be 0 because x-axis and this is parallel to each other. So this is the direction of x-axis, this is the direction of the line, so the angle it forms with the x-axis is 0. Angle is denoted with theta. Theta is the angle with respect to x-axis. This is theta, Theta. This is a Greek alphabet. So here theta is equals to 0. Whenever theta is 0, so slope will become 0. If slope is 0, then velocity is also 0. This is another way of looking at it, depending upon the slope of line, which represents velocity, displacement, time graph. Okay. Second graph time in hours. This is displacement in kilometer. So the body is starting from 0 and it travels 20 kilometers, say this point. So this point is basically, it is taking 1 hour, time is 1 hour, x-axis represents time in hours and y-axis represents distance or displacement in kilometers. So in 1 hour the body is covering 20 kilometers. In 2 hours the body is covering 40 kilometers. In 3 hours 60 kilometers. In 4 hours 80 kilometers. So say we take T1 to be say 2 hours and T2 to be say 5 hours. We can take any two, it does not matter over here. So in T1, S1, T1, when T1 is 2 hour, for 2 hour displacement is 40 kilometers and for T2 for 5 hours displacement is 100 kilometers. So velocity is displacement by time. So in this time interval 2 to 5 hours, from 2 to 5 hours means it started with 40 kilometer, reached till 100 kilometers. So total distance will be S2 minus S1. S2 minus S1 and the time taken will be T2 minus T1. So velocity becomes S2 minus S1 is 60 by T2 minus T1 is 3, that is equals to 20 kilometer per hour. So as you can see, in 1 hour it covered 20, in 2 hours it covers 40. In the second hour means starting from 1 hour till 2 hours, it covers 20 to 40, that means 20 kilometers. So every hour it is covering 20 kilometer. So since it is covering 20 kilometer every hour, this body is traveling with a uniform speed. So when the line is a straight line, you can conclude that the body is traveling with a constant speed. Body traveling with constant velocity. Okay, this is a straight line. Body is traveling with a constant velocity. As you can see, this is also a straight line. So here also body is traveling with a constant velocity, and the value of the velocity is 0, which is constant over here. Okay, third graph. So in third graph, we'll just discuss some basic only. Let's consider this. So let's take this point and say this point. So at this point, the angle it makes, this is the x-axis, y-axis. This is called the x-axis, this is called the y-axis. Where they meet is called the origin, represented with O. Say this is T1. Say this is S1. At this point, say this is T2. And this is, say, S2. In y-axis, this represents S, this represents time. Okay. So the angle, okay, this is a curve. With this curve, at this point, if we see the body as it was moving, so from here, this is the direction in which it was traveling at this moment of point. This is changing its direction every moment of time. At this point, it will be in this direction. At this point, it will become in this direction. So every moment of time, it is changing. Initially, it was in this direction. It's changed to this direction, then this direction, then this direction. So in the initial point, let's take the angle to be theta 1, and over here, the angle to be theta 2. Since the initial angle, that's why theta 1, and the another angle, second angle, that's why theta 2 we are saying. As you can see clearly, this angle is smaller than this angle. The greater the separation between the two lines, the greater is the angle. This is small angle, this is greater angle, this is much bigger angle. So the separation between the lines is much more. So this one is a greater angle, this is a smaller angle. So here, theta 1 is less than theta 2. So slope 1 at this point is less than slope 2, and slope in displacement time graph represents velocity. So velocity 1, velocity at, or say V1 will be less than V2. So V1 less than V2 means the velocity is increasing. With time, the velocity is increasing. So body in an accelerated motion. Accelerated motion. This is increasing acceleration. Okay. You don't need to write this one. Please do not write this one. Increasing acceleration. This will come in velocity time graph. Okay. Fourth one is body in retarded motion. next graph is like this. X-axis, Y-axis, origin. Okay, let's take again 2 points. Say this point and say this point. So we'll draw a line parallel to the x-axis in both the case. Let's say this is T1, T2, this is T1, this is S1 and this is S2. This represents displacement, this represents time. Okay, again we'll draw tangents. This is moving in this direction, so at this point of time the direction is in this way, and as this is moving over here, this point, this direction, this point will be this direction. So this one, let's say this makes angle theta 2 and say this makes angle theta 1 with the x-axis. We can take any line parallel to the x-axis, since at this point we are taking, so we're making this line parallel to the x-axis at this point, and for the other point we are making line parallel to the x-axis over here. So here theta 1 is greater than theta 2, since the separation between these two lines is greater over here and this one separation is smaller, so theta 1 is greater than theta 2. So slope of 1 is greater than slope of 2. As slope of 1 is greater than slope of 2, velocity of 1 is greater than velocity of 2. So as you can see, the velocity is decreasing. Initially it had more velocity. As the time is increasing, velocity is decreasing. So decreasing velocity means retarded motion. So the motion here is retarded. Negative acceleration is basically retardation. So if velocity is decreasing, so acceleration will be negative, hence it is a retarded motion. Okay, I guess looking at this diagrams with pencil will be a little difficult for you. I'll make the remaining graphs with pen. I think that will be better. Okay. One example, say for you're given a graph like this, displacement and time graph. Say you're given two lines, this one and this one. Let this make an angle theta 1 and this make an angle theta 2. You may given XY angle. I am taking theta 1 and theta 2 because theta is the standard way of denoting an angle. So as you can see, the separation between the x-axis and this line, for which case is it bigger? For theta 1, this is bigger because this x-axis and the line over here, see this is V2, see this is V1. So first of all, straight line means constant velocity. So these two lines are representing two different motions. So V1 has a smaller angle, V2 has a smaller angle, and V1 has a larger angle. So theta 1 is greater than theta 2, which implies slope of line 1. See, this is line 1, this is line 2. So slope of 1 is greater than slope of 2. If slope of 1 is greater, then V1 will be greater than V2. So if you are asked, suppose in MCQ, or you might be given to say that V1 is greater than V2, give reason why. So you need to reason here that showing these two angles, and since this angle is greater than the other angle, so slope of this first angle is more than the slope of angle 2, hence the velocity of 1 is greater than the velocity of 2. This will be your reasoning. Okay, with this we come to the end of displacement time graph. Next we'll discuss velocity time graphs. Okay, again notes. First one is that the slope of line in velocity time graph represents acceleration. Second part, the area under velocity time graph represents displacement. Okay. Velocity time graph is not so difficult. We'll see graphs similar to the graphs we saw in displacement time graph, but it will be completely changed. The understanding will completely change because instead of like this displacement in the y-axis, we'll be taking velocity. Okay. So first graph is this one, y-axis, x-axis, origin. Similar to the first graph we saw in displacement time graph. Say this is velocity, this will be velocity, say in meter per second, and say this is time in seconds. 10. Say this is 30, 40, 50, say 1, 2, 3, 4, 5. Okay. So see, when the time is 1 second, velocity is 30 meter per second. Here in the previous case, we saw that the displacement was 30 meters. Here the velocity is 30 meter per second because y-axis here represents velocity. In the second, the velocity is again 30 meter per second. In the third second, velocity is again 30 meter per second. In the fourth second, again the velocity is 30 meter per second. In the fifth second, again it is 30 meter per second. So here with changing time, velocity is constant. So here, like in the previous case we saw, with changing time, this displacement was constant. So here angle was 0, slope was 0 and velocity became 0. Here displacement was constant. Here the body was at rest. Here body is moving with constant velocity. Okay. In the previous case, we saw for displacement, theta was 0 since it was a straight line parallel to the x-axis. Here also the angle formed with the x-axis is again 0. So theta will remain 0 itself. That is not an issue. So slope again here is 0. As theta is 0, slope is also 0. If slope is 0, slope in velocity time graph represents acceleration. So here acceleration is 0. So acceleration becomes 0. If you correlate with the definition, acceleration is change in velocity by time. Since the velocity is constant, since the body is moving with constant velocity, so change in velocity is 0. As change in velocity is 0, acceleration should be 0. We can correlate with the definition as well as using slope. Okay, so slope here is 0, so acceleration is 0. But say, calculate, say a sub question is there. Calculate the distance, the displacement of the body between 1 second to 4 second. So solution, what will be the solution? We'll mark this as A, B, C, D. So this is a rectangle between 1 to 4 second. We need to find this area over here. So solution will be area of A, B, C, D, which will be equals to length into breadth. The length is, this is 4 minus 1 into breadth is 30. So 4 minus 1 is 3. 3 into 30 will become 90. Velocity is in meter per second. Time is in second. Meter per second into second is meter. So the displacement is 90 meters. So this is the type of question that you may get over here. You will not always get such simple graph. You might get different types of graphs for which you might need to find the area of a triangle or the area of a square, different figures. So this is first case where the body is moving with constant velocity. Okay. See, in this case, the second was we started from 0 and we took a straight line that was not parallel to the x-axis. So this was a slanting line. In this case as well, let's consider a line in the same manner. Since we took the last diagram starting with 0, let's not take this starting from 0. Let's take it in this way. So this is x-axis, this is y-axis. The point where they intersect is called the origin. This is time, say in hours. This is velocity, say kilometer per hour. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's say this is 1 hour, 2 hour, 3 hour, 4 hour, 5 hour. So this is 20 kilometers per hour, 40, 60, 80 and 100. So initially when the time was 0, the body started with 40 kilometer per hour. Then in first hour it reached somewhere here. In the second hour it reached somewhere over here. Third hour somewhere over here. Fourth hour it reached somewhere over here. Okay. So as you can see, this is a straight line. Okay, the diagram is not very well done because I am not using scale. Just try to get the point over here. What I am trying to say over here is, if you take any point, what is happening is, as this is a straight line, so the slope will be same all over the place. Like we saw over here in the second case, here velocity was found as constant because the slope was constant. Here, let's consider so theta here is constant. So as theta is constant, slope is constant. As slope is constant, slope in velocity time graphs give acceleration. So acceleration will also be constant. So the body is moving with constant acceleration. Okay. I'm not doing the sum for area over here because the graph is not very well defined over here. But if you need to find the area between any 2 points, you can easily find the area using the area of a trapezium. Okay. Third graph. Just like in displacement time, we'll take a graph like this. We'll consider 2 points, 1 point here, 1 point here, x-axis or y-axis, origin, velocity, time. This point, say time is t1. This point, say velocity is v1. This point, say time t2, and say velocity v2. So over here, this is the direction. Over here, this is the direction. This is theta1, this is theta2. As you can see, theta1 is less than theta2. So this implies slope of 1 at point 1 is less than slope at point 2. So velocity, slope here represents acceleration. So a1 will be less than a2. So as acceleration at point 2 is increasing acceleration, body moving with increasing acceleration. We'll discuss an example for this a little later, but we'll discuss this. This is an important topic. I missed you the diagram. You can copy this diagram. This diagram is also fine, but we'll discuss a problem relating this. Okay, the fourth type of graph here. Again, just like in displacement time graph, this will make in this way. X-axis, y-axis, and the y-axis we are taking velocity, and the x-axis we are taking time. So let's say this point, initial point only. So say this is theta1. So this is t1, t2. See, this is the direction over here. So this is the x-axis. So theta2, v2 at this point, v1. And this is also the origin. So theta1 is greater than theta2. So slope at point 1 is more than slope at point 2. So acceleration 1 is greater than acceleration 2. So as the time is increasing, so acceleration is decreasing. So as acceleration is decreasing, body is moving with increasing velocity but decreasing acceleration. See, velocity at this point was 0. It is keeping on increasing. As this body is moving, velocity is constantly increasing. But as you see, the slope is decreasing. So slope decreasing means acceleration is decreasing. Okay. Now we'll come to an example. Okay. Let's take an example over here. Say 1, 2, 3, 4, origin. Say we are taking a straight line like this. So this is time in hours. This is velocity in kilometer per hour. So this is say 20, 40, 60, 80, 100, 1, 2, 3, 4. Okay. So this is an example of, this is a straight line. So slope is constant. Slope constant means acceleration is constant. The body is moving with constant acceleration. This is an example of this graph. Since this graph was not well made, I did not write a question here and solve it. This is quite similar. If you haven't copied this yet, make sure you copy this over here and solve the question also over here. You don't need to do this again separately. So, if you have done it also over here, that's not an issue. This is perfectly fine. Do this separately as an example. Say we are given, calculate the displacement between 1 second and 3 seconds of the body. So what we'll do here as a solution is 1 second and 3 second, we will name them as A, B, C and D. So displacement is equals to area of trapezium ABCD, which will be equals to half into sum of parallel sides. Over here, these two are the parallel sides, so half of AD plus BC into the distance between them is equals to AB. The distance between them means the perpendicular distance. So that is AB. So this is equals to half into AD is 60 plus BC is 100 into AB is 3 minus 1, which is equals to half into 160 into 2. So 2 and 2 cancels off. This becomes 160 kilometers. So the displacement of the body between 1 second and 3 seconds. So in 2 seconds, starting from 1 second till 3 seconds, the body covered 160 kilometers. So between 1 hour and 3 hours, not second. Okay, so this is a velocity time graph. In the next class, we'll discuss about questions relating them, and also we'll discuss this same topics in detail as well.